Okay, so members, now we are going to see how do we handle improper partial fractions. But please don't forget to subscribe to the channel. Now, there's a difference between proper and improper partial fractions. Proper is a partial fraction when there is power in the denominator is strictly greater than there is power in the numerator. So we base on the powers both in the numerator and the denominator to classify them. Now, a partial fraction is said to be improper if there is power in the denominator is equal, there is power in the numerator, and also when there is power in the denominator is less than there is power in the numerator. Look at these two cases. You start here, there is power in the numerator is 2. Here, when you try to expand this to get this answer, there is power in the denominator is 2. So these two are equal. So that one is an improper partial fraction. When you expand this one, you get something like this. You start here, there is power is 3 in the denominator, and here there is power is 4. So say that this power is greater than this. So that one is also improper. So if you have an improper partial fractions, you first make it proper by using long division. So if I'm adding now this, when I expand this, you get it. So I'm going to have to long divide this. So now you first long divide, I will handle this after this. So you long divide. Here you have, then here you have, when you multiply this and this, when you multiply now this and this, 3, then minus x, then that's what you get. Minus 3. So this goes here 1 time, then 1 times this x squared, 1 times this, you get plus 2x, then 1 times this, you get negative 3, then you subtract this minus this 0, negative 3x minus this, you get 5x. So here shall be having negative 5x. Then you start here, we have 0 minus minus, so this will give us plus 3. So we divide until we start this power is strictly greater than the power here. So start this power is less than this, there we stop. We only stop if it's less. So meaning that now the whole of this 3x over is equal to 2, we say the quotient, then plus the remainder over the divisor. But our divisor is the same as plus 3, then x minus 1. So after doing that, members, now the next thing is we consider this, and we start this is the linear and this is the linear denominator. So we consider now this. So now add negative 5x plus 3. Now we express this into partial. We have seen that now so that this power is 1 and this one is going to be 2. So it's proper. So to express it in 2, we say this is A. We start now, this is the linear numerator, this is the linear. We say if it's linear, then the numerator should be a constant. Then from there, you cross multiply. Then we start with this time this I have x minus 1, then plus b, x plus 3 equal to negative 5x plus 3. Why? Because if I multiply these two, this will cancel with this and this after cross multiplying. So after cross multiplying, this will multiply and will cancel with this. So we see, I said when x is 1, now this bracket will go to 0. I'll be having here 1 plus 3, it will be 4b equaling to, when I put here 1 and this, I'll be having negative 5 plus 3, which is negative 2. From here it starts, my b will be negative 2 over 4, which is negative a half. Now to set this bracket to 0 so that I have only one unknown, I say this to be 0, x should be negative 3. It's negative 3. Now I have here negative 3 minus 1, I'll be having negative 4a. Negative 3 plus 2, that's 0, equaling 2. when I put here negative 3 times negative 5, I'll be having 15 plus 3, which will give me 18. From here I start my A, it's going to be 18 over negative 4, which will give me negative 9 over 2. So now, meaning that the whole of this is going to be negative 5x plus 3 over equaling to now my A, which is negative 9 over 2 over, then plus my B, which is negative 1 over 2 over x minus 1. So now, meaning that the whole of this now is going to be this, then plus this by this is here. So now my minus 3x is going to be now 1, then plus, now where is this? I'm going to put this. Then plus, you can go on to simplify them the way you want. Now, when I count this, I don't divide, I'll get this, now I'll divide by this. So there, in number 2, I'll say now, I'm going to first long divide because it's improper. And we have seen now why it's improper. So it's x cubic. When I expand this, I get this plus x. Then up I have x power 4, x cubic plus x squared. You see we are missing x power 1. So I can put it there as x power 0, x, then plus 1. I mean 0x, then plus 1. So this one goes here, x, this time is this, x power 4, then this time is this, get plus x squared. Then you subtract this minus this 0, negative this minus, so you have negative x cubic, then this minus this goes to 0, then you have plus 1 surviving. Now we divide until this power, the power on this remainder is less. So it's that here they are equal. I still divide. So this goes here, negative 1. So this times this, I get negative x cubic. So this times this, I get negative x. When I subtract, this goes away. Then that here I have 0 x squared, I mean 0x minus minus to get x, then plus a 1. So that now this power is less than this power. So they have stopped. Meaning that the whole of this x power 4 is now equaling to, you say you get the quotient, then plus the remainder over the divisor. Our divisor was x into x squared plus 1. Now we consider this. So if we consider now x plus 1 over x into x squared plus 1, this is now see that this one is linear and this one is quadratic. And this quadratic cannot be factorized. So this is a over x. We said if it's quadratic, the remainder, I mean the numerator, is linear over x squared plus 1. So if we cross multiply, this side we have x plus 1 equaling to a into x squared plus 1, then plus the whole of this multiplied by x. So this one, when I multiply this and this, it will cancel with this and this, they will cancel. So to start with, is that I can eliminate here the whole of this. So when x is 0, this side I have 1 equal to 0 plus 1. Then I have 0 plus 1, so that my a is 1. 0 times this, it will go. The whole of it goes. So the other thing is now, I want now to remove b. When I want to remove b, still x will be 0, so that one is not going to work for me. So I can say, when x is say 1, when x is 1, Here I have 1 squared plus 1. This side I have 2. 1 plus 1 which is 2 because x is 1. Here I have 1 plus this, which will give me still 2a. Then plus I have here b plus c. And the whole of that one c, if I rearrange this, my a is 1. So it's that from here, my b plus c is equal to 0. Because a is 1, so when I take it this side, I'll be having b plus c equal to 0. You can use another value, say, which you can even see that your b is equal to negative c. So you can use any other value, say, but of course smaller values when x is negative 1. When x is negative 1, I have negative 1 plus 1. This will be 0 equal to negative 1 squared is 1 plus this. We have still 2a. Then when I put a negative 1, I'll be having plus. Now the whole of this is negative. Okay, I have negative b, then plus c, then times negative 1. This negative 1. So this one is already. Here I already have a negative 2. I mean, a, when I take this side, I have, here I have a negative and negative, I have b, then this negative and this positive, I have minus c equal to negative 2 when I take this side, because my a is 1. But because my b is equal to negative c, you see from here, I have now negative c minus c equal to negative 2. That from here, my c is going to be 1. And if c is 1, then your b is negative 1. From here. Now writing the whole of this is that now this one is going to be now x plus 1 over x squared plus 1 equaling to, equivalent to a is 1, so 1 over x. Then b plus negative x plus c is 1, the whole over x squared plus 1. Now writing the whole of this, it's going to be now x power 4. The whole over equaling to this. Then we say that the whole of this now is this plus 1 over x, then plus 1 minus x over x squared plus 1. So members, that's how we have the improper fractions. Don't forget to subscribe to the channel. I wish you the best.